Welcome to this tutorial on large language models, or LLMs. In this video, you will explore the basics of LLMs, how they function, how to interact with them effectively through prompting, and common issues with LLMs, such as hallucinations or generation of incorrect information. By the end of this video, you'll have a fuller understanding of how to get the best responses from LLMs. Let's go and get started. So, what exactly are LLMs? Large language models are advanced artificial intelligence tools that can understand and generate text, creating human-like responses. You may already be familiar with popular LLMs like OpenAI's ChatGPT, Google's Gemini, Microsoft's Copilot, and Anthropic's Claude. These tools are trained on massive datasets from sources across the internet, which means they've absorbed a broad understanding of language, concepts, and more. So, how do LLMs work? LLMs learn through a two-step process: pre-training and fine-tuning. During pre-training, the model learns general language patterns like predicting the next word in a sentence, using vast datasets from various domains. Fine-tuning, the second step, adjusts the model for specific tasks, making it more useful for targeted applications such as customer support, creative writing, or tutoring. LLMs are continuously developed through the data collected in human interactions. When we interact with LLMs, we do so through something called prompting. A prompt is just an input, usually in the form of a question or instruction. This is the way the model understands what we want it to do, and we can interact with the model the way we would with another person. The way we structure these prompts can greatly influence the quality of responses. Effective prompting can make a huge difference in how accurate and useful the output is. Here are some strategies for effective prompting. First, we have the most basic prompt, which is the zero-shot prompting, where you ask the model a question with no examples. In one-shot or few-shot prompting, the user gives one or more examples to help the model understand the context better. These can be example outputs or further instructions to the model. Another powerful approach is chain-of-thought prompting. By leading the model down a set of instructions, breaking down the task step by step, you can often get more detailed, accurate answers. Another good way of prompting is to pose an instruction at the end, asking the model to present questions to the user on what they want to generate. This helps the model get more relevant information, following a similar style as chain-of-thought prompting. Now let's go over some general best practices for prompting that will help you get clearer and more accurate answers from LLMs. 1. Be precise. State exactly what you want the model to do. Specific prompts reduce ambiguity and help avoid misunderstandings. 2. Assign a role. Tell the AI to act as a specific type of expert, like a historian or tutor. This can steer responses toward a desired tone or expertise. 3. State the purpose. Including the goal of your request can give the AI context, like asking for a summary versus a detailed explanation. 4. Ask open-ended questions. Phrasing prompts as questions like how and why can encourage more thoughtful, detailed responses. 5. Provide clear formatting. When you need organized information, use bullet points or specific formats in your prompt. This helps the AI organize its responses. Specify the desired output. Indicate if you want a list, summary, explanation, or code snippet. By default, the AI responds with headings, paragraphs, or lists, so give specific format instructions when necessary. A critical challenge with LLMs is hallucinations, where the model generates information that sounds correct but isn't factual. Hallucinations especially rise from the training data for the LLMs, which can include both factual sources and fiction, as LLMs can draw from both at the same time. Data limitations are also an important factor, as AI has a habit of filling in hallucinated data when it is lacking true data in the training material. An example of a hallucination might be asking the model,
When did the first person land on Mars?
and the model producing an answer in the lines of,
The first person to walk on Mars was John Smith, who landed on the planet in 2027 as part of NASA's Mars mission.
The response sounds plausible because it uses a common name and a realistic future date, making it seem credible, while the information cannot be verified against any reliable training data because it is not true and does not exist anywhere in the training material. Let's look at some ways to reduce the likelihood of getting hallucinated responses. 1. Verify facts. Always double-check AI-generated content, especially for specific data, facts, or statistics. Cross-reference with reliable sources to confirm accuracy. 2. Use clear and specific prompts. Be as precise as possible in your requests. The clearer you are, the less room there is for the model to make incorrect assumptions. 3. Limit complex queries. Avoid asking multiple questions in one prompt, as this can confuse the model and increase the chance of errors. You can use chaining prompts to feed complex tasks to the model. 4th, repeat key terms. Repeating critical keywords in your prompt can add weight to their importance and make the output emphasize them in the context. 5. Break down complex prompts. For intricate topics, use step-by-step prompting to help the AI address each part accurately. Long prompts can confuse the model and lead to inaccuracies. By following these strategies, you can greatly reduce the chance of getting incorrect responses and make sure the AI's output meets your needs. LLMs are powerful, but they do have several important limitations beyond hallucinations. Firstly, there is no thinking actor behind them, so they lack any real understanding. LLMs generate responses based on patterns in data. They don't understand the content. This means they can produce convincing but incorrect answers, especially on complex topics. They can say one thing in one sentence, and then the opposite in the following one. Secondly, they are very sensitive to prompt wording. LLMs can give very different answers depending on the phrasing of the prompt. Small changes in wording may alter the response, sometimes leading to inconsistencies. Thirdly, they are sensitive to biases, IAs, in training data. Since LLMs learn from vast datasets, they may absorb biases present in the data, leading to responses that reflect cultural, social, or other types of biases. Fourth, there can be limitations due to their data cutoff. LLMs are trained on data available only up to a certain date, so they may lack information on recent events or new discoveries, unless they are integrated with a search engine. But this does not always guarantee information validity. Lastly, most LLMs have filters to prevent generating harmful or political content. While this is essential for safety, it can sometimes restrict legitimate queries or limit the model's responses in sensitive areas, which can even include news on current events. Knowing these limitations can help set realistic expectations for what LLMs can and can't do, and it reinforces the importance of using them as helpful tools rather than as definitive sources of truth. To wrap up, remember that LLMs are powerful tools, but they have many limitations. With effective prompting and a critical approach, you can guide these models to produce accurate, useful answers. But always remember to verify information from credible sources. Let's start practicing these techniques with some exercises and learn about important concepts and prompting practices.